Welcome back, everybody. Welcome back to the channel. So today we're going to talk about how to parse our first statement. So we're going to go to parse statement here, and before we actually get into this, a few housekeeping things. I fixed several bugs, so let me try to do what to do here. So there was a couple of bugs that I found. So one bug that I found was that, like for instance, let's say, oh God, okay, so I have to close, let me close some of these really quick. So let's say you have, this dot notation call expression. You guys know what this is. So whenever you try to call a function, functions can return things, right? So we can have a function called foo, and our foo can return, whatever it wants to return. It can return an int, or it can return a var, whatever. But if you guys remember, we also can return function pointers. Now, because I'm a bit slow, and I guess I didn't realize, this is kind of a late feature anyway, so I guess it makes sense. But if you try to call foo, and then you try to call the function that it returns, it wouldn't work because I didn't support calling functions after you call a function, which is a bit of an interesting thing in itself, but nonetheless, I didn't support it. Also, this has what if foo returned a function pointer that took a integer and a string as parameters? Well, then you're gonna have to pass, 100 and then, I don't know, hello or something, as the parameters, and you're gonna have to be able to execute that. So that was something that wasn't supported. It's pretty simple. Literally, I just copied this code here. So you guys can just do that. Just copy this, paste it right below increment check, and you just have to modify it slightly. So we have to basically check to see if the next token is equal to a left paren. So we support all these things here. I'm going to add another one. So I'm going to say or function, and we call a function after we call this function. So we check to see if the next token is a left paren. We then create this ast.function expression, just like we do down here. You don't want to encapsulate it like we're doing up here because you want it to be tacked on to the end of this ast, so that way it can be a little easier to process. So once you do that, all you do is just call the same code that you called here. So you just say parse expression list, and you set the begin and end char to parentheses, and you just call go to increment check. That way, what if, this function pointer that you're calling returns another function pointer? Now, I know this is extreme, but you can basically infinitely return function pointers. And this hurts my eyes just looking at it, but you can do that. Or technically, let's say you have an int or something, then you could say dot value or dot get value to get the value of the int or something, or just whatever you want to do. So we just want to be able to support that, or plus plus, whatever. That way we can still do all the same things that we can do after we call a normal function the normal way. So there's that bug fix. Let's look for another one. So I have this one as well. Now this one was a bit interesting. So basically what this bug was that so if we have a variable, right? I can create one called x, and let's assign it to 325. So if we assign x to 325, and actually this is a method declaration, okay? So it's not a field declaration. So I'm gonna say define. So you guys remember, right? There's a couple ways you can basically create a function. So you can do it the normal way where you just have a block. You can also create a function delegate, and you can also do what's called an inline function declaration, which is, just saying this function equals this expression. So we could say new int of, I don't know, 30 or something, and then that will effectively foo now returns the int class. We could also explicitly declare the type that it needs to return and still use the same inline syntax where we can basically just use an expression. But there's a problem with that. So if we look here, we have the situation where, and this happened in both places. So we have the situation where we have a colon, and then we try to see if the next token after the colon, so we have this colon, we process our utype here, so we process the method return type, and then we check to see what's the next token. The next token is an equals or a semicolon. If it's an equals, then we just parse an expression, totally fine. If it's a semicolon, totally fine. And if we go into parse block, now, I mean, you still need to put this fix in. You don't have to worry about it too much for right now. We'll get into parsing all the statements soon. But if we look at parse statement, if we scroll all the way to the bottom, it allows us to basically process an expression. Because at the end of the day, if you process or if you try to process every single type of statement, the last resort is to try to process an expression, because technically expressions are statements. So what that effectively allows you to do is, if you remember, you don't need you don't need the brackets for block. So you could literally just like do this and say foo int and then just do that without an equal sign. So I just basically force it to have the equals after the expression or before the expression. So what I do is I check to see if the branch, and I get the last token, which is created by parse block. I get the sub AST, and I check to see if it's singular. What this function does is it just checks to see if the len is equal to 1. I'm lazy, so I created this singular function because I didn't want to put like len is equal to 1. But yeah, so if we do that, then we check to see if the last sub AST, and we get the sub AST at 0. So what we do is we get this sub AST, which is the last sub AST, then we get the sub AST at 0, which will represent statement or block. Now, if we go back, we can see, so then we get the type of that AST. So if it's equal to AST underscore expression, then what we'll do is we will complain about it. So if we get the block from last sub AST, we get sub AST at 0, which is the statement inside of block, or potentially if it's block, then you'll get, whatever's inside of there. Um, and we go inside of statement theoretically if this was the AST statement. And if it's equal to an expression, then that's how I basically figure out that, oh, we processed an expression here and this is ugly. So they need to, do something with that. After that, it's basically the same code. So I put it in both spots. If you have a block and you basically so for like the case where you don't have a colon, you don't have an infer symbol, like you don't have anything. So you could also technically do this. You could just say foo new int. That's bad. You want to be able to at least force the user to have to say like what is the return type, or have them put an equal sign or denote that this is the start and end of a block. So just want to make sure they do that, and that's that bug fix. Let's see, do I have any more? I don't. Okay, so let's get into what we're going to be talking about today. So if we go to parse statements, now we're going to start parsing statements. Now, if you guys haven't, put in the code for parsing a block, I would definitely recommend checking my older videos to see how to properly process a block, so that way you're up to speed. But let's look at our first statement. So when we're starting to process statements, and I believe I mentioned this in a previous video, but what you want to do is you want to start off by creating a branch called AST statement, and you want to check your error limit, because theoretically, like, functions are huge. As you're processing, you could be processing several thousands of lines of code, and you want to make sure that if you're parsing it and there's like an error while you're parsing statements, you're not just looping forever in some weird like loop or something. So you want to just return false, which basically denotes that you didn't parse the statement properly if we crossed our error limit. So you can see here what the code kind of does. So after that, we do our access declaration checks. This is pretty standard. We do this everywhere. You just free up the access types. If there's an access declaration, you parse it, blah, blah, blah. So today we're going to be talking about how to parse a return statement. Return statements are what you need to return in every single function. You need it. It's essential in every programming language. So the first thing you need to do is create your is statement, and the value is going to be returned. So we just check to see if the current token is an identifier and the value is equal to return. Once you do that, then you want to check to see if there are any access declarations declared. It does not make sense for the user to say public return. Like, that doesn't make any sense. So we just want to make sure that they don't do that. Of course, we return true immediately because we know that in fact we have successfully processed a statement, or the one that we were looking for, and then we go into parse return statement. And as you can see, the function is very tiny. So we have our AST return statement AST here that we need to create, or our branch. What you want to do is you want to consume the token. I don't think you don't need this. You actually don't need this token here. You can just say advance and just like skip over the token if you want. Um, so after you do that, once you consume the return value or the return token, then we want to check to see if the next token is not equal to semicolon. The reason being is if we have, so like, better yet, here, I'll do this. So we have like this foo function, and this foo function returns nothing. Technically, you can just do that, right? And what that'll do is just return out of this function, and it won't return anything. It'll just break out of the function. So that's why you want to do that. Otherwise, so if it ends up not being a semicolon, then we parse an expression, and we expect a semicolon, and that's pretty much it, guys. Return statements, this is probably going to be the easiest statement possible that we're going to process, but on the back end, actually processing this is very complicated, and here's why. Now, I know this is kind of just a video talking about how to parse return statements, but I just want to put something on you guys' mind when you're building your programming language. There's certain scenarios that I've ran into that I've recently fixed where, like, what if you have, like, in this foo statement, let's say we create some integer. So say array or int array, and we assign that to a new int of, I don't know, 10. So we create 10 ints, and now we have this array. Let's say we wanted to lock this statement. So we want to say lock int underscore array. You know what? Actually, hold on. I'm actually gonna go to Atom because I absolutely hate this syntax. If you guys ever used Atom, it's really nice. I will be making a video pretty soon talking about how to put syntax highlighting into, or how to support it in C-line. Instead of me just like doing it on my own, I'm actually going to just put it into a video because I'm pretty sure some of you guys are curious about that. But for now, I'm going to use Atom. So where is it? So it's like grammar, C#. Okie dokie. So let's say we have this foo function and we create this int array and it's a new int. We want to lock this int array, and like let's say in here we want to do some stuff. So we do some stuff in here and then we call return and we just return out. Well, how, as a user, you're going to have to basically figure out that they're inside of a lock statement, and you're basically going to have to release this lock before you return. Now, I know that may seem simple, but it's not. And here's why. What if you have like an if statement? So if, I don't know, int, because technically what like my original solution was to say, well, is the current statement that we're inside of a lock statement? Well, that's easy. But what if you're inside of a for loop? I is equal to 0, I is less than 100, I plus plus. And then in there, like let's say you're inside of an if statement. So if I is equal to 9, and let's say we're also in a try catch. Now I know I'm being extreme, but there's a reason for this. So finally, we have a finally block, and we also have, let's say we catch an exception. So we have all of this garbage, and we want to basically return. And when we return, what we want to do is let's say we do some code in here. So let's say we say, I don't know, print, we're done. And if you guys remember, finally blocks are always guaranteed to execute no matter where you are in the code. So this is a very complicated statement. So, and here's why I said return statements are extremely complicated on the back end. You have all of these statements, right? They're all nested, and you're trying to return out of this function. Well, what happens is you have to basically call this finally block, and you have to know how to release the lock of this variable. Well, how do you know that? Do you have any idea how many ASTs back this is? Like, this is one AST, this is another AST, this is like, and then it's like 3 ASTs nested deep. So how do you know, that you need to basically unlock this lock statement? And to that, I guess you could say, well, why don't you just have like, current lock expression, and I don't know, like say like this is the current variable or the current thing that you're trying to lock. That's easy. But now let's say we add another variable into the mix. Let's say we have int array of 2, and then we say lock int array2 and there, and now we have to release two locks. Like, it gets really messy. So I just wanted to give you guys something to think about. We are going to be going over this a little bit later. This is really complicated, but yeah, you have to basically, right before you return, call this code here for the finally block and execute unlocking both of these. It also gets even weirder, like when we get into continue and break statements. What if you call continue, right? Well, if you're inside of a lock, now you have to figure out, okay, if you guys remember, continue statements basically jump to the top of a for loop. So technically we're going to get out of scope and we're not going to have, we're not going to be in the scope of this lock anymore. So like, let's say, this lock was actually inside of here, inside of this for loop, and that. So let's say the lock for this was actually inside of the actual for loop here. And now we're calling continue. We need to jump to the top. We need to release this lock, and we also need to call this finally block. How do we know to not release this lock? Just want you guys to think about that. So if we go back to our parser, let's actually see how this code looks. So I'm going to go to my compiler, and what is it? Parse statements, right? No, it's compile statement. Compile statements, return statements, and I'm going to say, whoops, AST toString. All right, so if we look here, and I have no idea where this code is actually being called, but I guess we can see an example where we just have a return statement and a simple number. So you can see that we have an AST of AST return statement, a AST expression, primary expression, literal of 0. So we can see return statements are not that complicated. It's just basically this AST type here of return statement and then whatever the expression that we're processing. So hopefully that made sense. As usual, if you guys have any questions, definitely write them in the comments section below. And of course, if you guys would love to help support the channel, definitely head over to my GitHub repository at enterdevcd/sharp. And when you guys get there, definitely watch, star, and fork this repository. That's going to give this repository a lot more visibility and let other developers know this language exists. Also, if you guys are curious about learning the things that I do on a daily basis with the language, you can check out the remastered branch. And when you guys get there, you can check out my commits. I write some pretty wordy commits, so you can kind of get a gist of what I've been up to and the various things that I've been doing in terms of bug fixes and updates without really having to go too much into the code. Also, if you're curious about maybe some of the things that I've added in the past to the language or even stuff that I'm looking to add into the future, you can check out the doc folder, and that's going to contain two main files. One is going to be the changeless file. It's going to be pretty much everything that I have done in the past in terms of updates and everything else. And the roadmap file is going to pretty much contain everything that not only have I done in the past, but also stuff that I'm looking to add in the future. So definitely recommend checking this out. It gives you a lot of insight into the language. So that being said, thanks for watching the video today, guys. As usual, if you guys are new to the channel, definitely consider subscribing. Until next time, I'll see you guys later.